Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand and do chemistry at home in your everyday life.
Wow, that was a really good one. Okay, Jam, I sent you on a chemistry experiment.
Yes, you
this
did.
week.
Mm-hmm.
You had to buy some red cabbage.
Mm-hmm.
And then tell us what you did and what happened.
So I got 6 different mugs, clear, which you guys can see in the video, obviously. If I were you and you haven't already watched the video, then I would listen to this first and then go watch it on our various social media channels. But I put some baking soda and water in one mug, some sugar and water in another mug, some water and water in another mug, some carbonated water with some lime flavoring to it in another mug, some vinegar in another mug, and then some lemon juice in another mug.
Perfect.
So those are all in a row. And then per your instructions, I put some water and some of the leaves of the red cabbage in a blender, blended the heck out of them, which got so purple so fast. It was very interesting. And then I filtered that cabbage mush through a coffee filter. Got to use a little coffee equipment. And then got this very, very deep purple, cabbagey, watery juice, which I did not try to drink. No,
I'm not sure it would be very tasty.
And then, per instructions, I poured a little bit of that cabbage juice into each of the mugs of different substances.
And what happened?
They all tasted really bad.
No, don't let your kids taste it. I mean, I guess they're all food safe, but
yeah, I did not taste them. They all reacted a little bit differently in terms of color. So the baking soda turned blue. The baking soda and water one turned blue. The sugar and water one turned blue, and the water and water one turned like a slightly purplish blue. And then, so those are all bluish, different shades of blue. And then the next 3 were all in the pink red category. So there was the carbonated water, which I poured it and it immediately fizzed a lot. And then it was like a really light pink color. And then the vinegar turned like a pretty deep, almost red, like pretty dark pink kind of thing. And then the lemon juice turned like a medium, kind of classic medium pink. And yeah, so that was very, very cool and interesting. And ended up having a little bit left over of the cabbage water. So then I went another round and poured a little more just to try to make the colors a little stronger and see if the differences between them would be a little more clear, which definitely helped on the blues. It helped them be a little more obvious how different they were from each other. But it was super cool and very surprising.
I'm glad that you thought it was super cool. I was planning on going to Jam's house this morning and standing outside safely, socially distanced, and doing the experiment, watching him do it so that I could see it, because I've never been able to do this one myself. I've seen people do it in labs, but then we got rained out.
Yeah. I was actually going to mention that in the video,
kind of a bummer.
And I forgot to, but that's why I was doing it inside instead of outside. I almost always do these outside because the lighting's better and in case I make a mess. But this one was inside because it's been a dreary day a little bit.
Right. Well, it was kind of nice because I got to sleep in a little bit longer, but it was sad still.
Yeah. So you have to watch the video also to see what happens.
Yeah, so I'll watch the video, but I'll tell you what is happening here. Is in chemistry, we have what's known as an indicator.
Okay.
So an indicator, just quite like it sounds, is something that gives an indication, usually based on color, to the presence of some kind of chemical.
Okay.
So in this case, it is an indicator of acidity.
Oh, okay.
So the more acidic the material, it goes to red. The more basic, it goes to blue.
Ah, interesting. I did hypothesize a little bit in the video about how the cabbage water is purple and how none of the things ended up being purple. They ended up either being blue, which is obviously purple made up of blue and red, or ended up being on the red side. I was like, oh, interesting that they went either direction like that.
Right. So really what happens is in the presence or absence of acid. An acid is usually just a hydrogen atom that has lost its electron. So it's usually denoted as H+.
Okay.
So in the presence or absence of these protons, these H+ hydrogen atoms without its electrons, it will go to one form or the other. So in one form, it's blue, and the other form, it's red. So it just shifts around some bonds that make it absorb and reflect different light.
Oh, dude, interesting.
So it's usually indicators are blue for basic, and just most of the time, blue means basic, and bases are also kind of bitter, so all those are Bs. And then red is acidic, and it's not really bitter, so I would think that. Maybe sour, I don't know.
Yeah.
Okay, so guess what this nice red indicator is? It's something that we've recently talked about and seen.
Huh.
That's red.
Seen and talked about that's red. Is it one of the things in leaves in
Yes.
When we talked about changing colors of leaves? Oh man, I can't remember what the name of those are.
It's a type of anthocyanin.
Nice. Dude.
So it's the same thing that's in the trees that's present in the plants, and so you can isolate the abundance of it in red cabbage.
Ah, anthocyanins. Very cool. That totally came full circle.
Yeah, I know. I was very excited about that. So your kids probably won't care about that, but you could maybe tell them, oh, this is also the same thing that makes the trees have red color in it, something like that. But some good questions to ask your kid for this is to get them invested. You can ask them, what color do you think the cabbage water is going to be when I blend up this cabbage and water? Then you can ask them, what do you think is going to happen when we add the cabbage water to to that, and try doing different things. And then you can ask them, why do you think the color changes? I've said this before. I wouldn't worry too much about them getting the perfect right answer. Oh, when it's acidic or basic, this or that happens. I would just focus on getting them to think about what's happening and use those critical thinking skills and make guesses about what's happening. That is the thing you want them to do. So if they're younger and they make a guess, you can say, yeah, there is something in each of these liquids which makes it change color. And if they're older kids, you can talk about the acidity, and that's measured on a scale called pH. pH basically just means it's the inverse log, if you type that into a calculator, of the concentration of ions. So it's just a measure of the concentration of the acidic ions that are present in this solution. So that's all pH is. So you can talk to them about if there's a higher pH or a lower pH, the concentration of acidity would be different. And then you can do my favorite thing, which is ask them what other things they want to check the acidity of. So you could maybe mix some shampoo, or I saw one where they did toothpaste. They did a toothpaste in water solution. And if it's food safe, you can let them try all those things and add it to them and then group it. Is it acidic on the red side or basic on the blue side? I would err on the side of clear things. That's going to usually work better for you, or lighter colored things. Dark sodas don't usually work because the color will just cover up the color of the cabbage.
Got it. Okay.
And then I do want to say, though, don't put things that aren't food safe in food containers. If you want to test something that you would not let your kids eat, you probably should put it in a plastic container or something disposable. Not that we want to use plastic, but don't put it in a food safe container.
Got it.
A fun one is bleach, because if you use bleach, it will usually just totally decolorize the cabbage solution because a different reaction is happening.
Oh, interesting.
Because it breaks those bonds like we talked about in the episode about the bleach.
Yeah. You mentioned
how bleach works.
Maybe trying to do bleach, but I couldn't find a container to use that wasn't one of our ones we want to use for food. And so I didn't end up doing it, but dang, that's interesting.
So this is a fun way that you can introduce your kids to the concept of chemical reactions. A plus B changes something. You are introducing them to the idea of acidity if they're a little bit older.
Mm-hmm.
You are getting them to use their critical thinking skills, and then you can get them to explore the house and think, what other things could we test? So it's a good way to get your kids in a scientific mindset and get them to practice using that science mind.
Mm-hmm. Dude, yeah. This is a cool one for sure.
Did you get excited? Did your science mind start going?
Oh, yeah. It really did. Can't you tell? Do I look different?
You look more sciencey for sure.
Oh, I knew it. But like I said, like we're talking about that, and then suddenly it's like wearing a lab coat. It's like it just appears. You're doing it. Your science mind's working.
One other thing you can do is I told Jam to put it in the order of reds to blues, but you can mix them up and then they won't know what to expect or which one. And you can put them in order of the darkest blue to the darkest red, and that would be the most acidic,
Mm-hmm.
so you can do different things like that.
You had me do it blues to red, right? Not red to blue.
Yes.
Yeah.
Oh, well, I mean, yes, I just had you line it all up.
Yeah. You had them grouped by the color. Yeah.
Yeah.
That was funny too, because I thought, I guess they're all going to just turn various shades of blue. But then once I had the first pink one with the carbonated water, I was like, oh, nice. So it's kind of like you set it up like, oh, it's just going to be lots of blues. And then it's like, nope, fizzy reaction. And then it's pink suddenly. It was just pretty cool.
That's fun.
Yeah.
I'm so glad that you enjoyed that. That's really great.
So you guys should definitely check out the video of this to see how we did it, and then do it yourself and do some of the tips that Melissa said about trying other things too. I'm pretty curious about some of the other substances in my house, if they're acidic or basic or whatever. But dang, very fun.
I'm so glad you liked it.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. And we'd like to give a special thanks to E. Robinson, who reviewed this episode.